So we're going to graph f of x equals log base 2 of x. First of all, remember what log base 2 of x means. This means that 2 to the whatever f of x is equals y. I'm sorry, equals x. Let me rewrite that. Remember, f of x is just your y. So log base 2 of x is the same thing as saying 2 to the y equals x. So we're going to make a t-chart, and we're going to be very smart with what we're picking for our x values. Our x values that we want to pick to go in there are all going to be powers of 2. So one of the powers of 2 is 1, because 1 is 2 to the 0 power. Right? So one of your points is 1 comma 0. There's one of your points right there. Another power of 2 is 2. 2 is, remember what I'm doing is that's what I'm putting in for x. 2 to the first equals 2. So when x equals 2, y equals 1. Then another one would be 4. If x is 4, what's y?
2.
It's 2. Good. And then we can also go negative. If x is, actually what we're going to have to do is we're going to have to go 1/2. If x is 1/2,
-1.
then -1. Y is -1, because 2 to the -1 equals 1/2. This is your x, and that's your y. And we could also do 1/4. 1/4, -2. And then it's going to be 8. Another point's going to be 8 and 3, or 1/8 and -3. So you see what the points are? Let's start plotting those points. The closer and closer and closer I get to 0 as I'm plugging in x values, the further negative that's going to be. There's a point right there at -1/2. There's a point right there at -1/4. If I go another way, it's all the way down to here, and then etc. What's going to happen is it's going to get closer and closer and closer to that y-axis, but it's never going to touch it. And as I go to the right here, when x is 2, y is 1. When x is 4, y is 2. When x is 8, 5, 6, 7, 8. When x is 8, y is 3, etc. So this is what the graph looks like. And that graph, I'm going to go ahead and erase some of this so you can see what the graph is basically. It is the inverse of the exponential graph. So I'm going to do this one in green. If I take the x and the y and I interchange them, and now if I solve it for y, which I can use the equivalence y equals 2 to the x, y equals 2 to the x, that graph right there, which is just this graph, 1, 2, 2, 4, 3, 8, and it's going to 0 there. What's that graph right there? That graph is the reflection over the line y equals x. Those are reflections of each other. So that's how you graph a logarithmic. That's the long version of graphing a logarithmic. Now let me show you the shorthand way of graphing a logarithmic. So what we're going to do is we're going to use our base graph, which we know looks like a flipped exponential graph. So our base graph is, it's going through that point, it's going like this, and it's approaching the vertical asymptote of the y-intercept. If I have, let's say, g of x equals log base 3 of x minus 1, that 3, by the way, and that 2, it's kind of like 2 to the x and 3 to the x. Are they really very different? Those graphs aren't very different. They're just one steeper than the other. It doesn't change where it goes through the x-axis, and it doesn't change your asymptote. It just changes kind of your steepness of your graph. Well, what did I just do when I made that a -1 right there?
You moved it over to the right.
I transformed the graph, and I transformed it by moving it to the right. So this, my new asymptote is going to move one to the right also. So there's my new asymptote, and there's my new point, and it's going to do like that. And if it was, let's do a different one in green. If it was log base 3 of x plus 1, all I did is I took that original graph, which was that first black one that I graphed there. Let me go ahead and erase that second one so we're not confused. This first black graph right here, and I'm just moving it up 1. So every point moves up 1. This point moves up 1. All of these points move up 1. So it's going to look like this, and it's still going to go down, and the asymptote's going to be the same. If you put a 4 in front of that, all that does is change the steepness of it. It makes it rise quicker, but it still is the same shape. Actually, this 4, that right here would be up here somewhere. It just makes it steeper, but your asymptote hasn't changed. It just makes the graph steeper vertically. Or if it was 1/4, it would make it less steep vertically, etc. So it's all those same transformations that we've talked about before, but it's with a logarithm. So that's a quick little tidbit about logarithmic graphs and how they relate to exponential graphs. So the point, again, that I want to get across is when you see something like log base 3 of x, the easiest way to graph this is to make a t-chart and pick nice numbers to go in for x. Powers of 3. 1, 9, 3, 9, 27, 1/3, 1/9, etc. Because then it's easy to find what the values are of y. The values would be 0 or 1, 2, 3, or -1 or -2. So don't make it difficult. Don't pick like you used to do. Don't pick -2, -1, 0, 1, 2. There's no reason to pick those because those are going to be ugly decimals, and that's not going to help you very much. Pick nice numbers for x, because remember that's the independent variable. You can choose whatever you want, and then find the values for y based upon it, and then graph that.